Hey everybody, what is this shape? Most of you, hopefully, anyone who's been through first grade or so knows that this is a parallelogram, right? Where we have two pairs of parallel lines that cross, and then that makes this parallelogram shape. So we're in 9.1, we're going to do 9.1, 9.2 together because they're very similar. 9.1 deals with the properties of parallelograms, right? So what is a parallelogram? What's true about it? And we basically just, they're labeled as theorems, but they're just properties of parallelograms. So the first property is that opposite sides are congruent. So if I have my parallelogram here, I can say that AD is congruent to BC, assuming I know this is a parallelogram, and AB is congruent to DC. So that's one thing I can figure out. Another thing that I can figure out is that, not one up here. Opposite angles are congruent, right? So we can look at this and we can say, oh hey, this angle here is congruent to this angle here, and that should make sense. We can say that this angle here is congruent to this angle here. Okay, so hopefully those are pretty intuitive. We also have a few more. We can also say that the diagonals bisect each other. Oh, before I do that, one more property with these angles. What's true about, say, we'll call this angle A and this angle B. What is true about angle A plus angle B? Hopefully we should figure out that any two consecutive angles, either A plus B or B plus C or C plus D, equals 180, right? They're supplementary. So that's another property that may come up. I'm not sure. So the diagonals, so if we draw a diagonal through this quadrilateral, they bisect each other. So we're saying that this segment here is congruent to that segment, and this segment here is congruent to this segment. Right? That's what it means to be bisected, is cut in two even halves. So that's our final property for parallelograms. Okay, and then we just can apply this to different problems. So for example, we have this. It tells us it's a parallelogram. So since we know it's a parallelogram, we can conclude all of these things about the properties of a parallelogram. So for example, if we want to find the length of AD, we know that AD is equal to BC. BC is 5x plus 9, AD is 7x. Therefore, we can set them equal to each other and solve and calculate for what it is. Okay, angle B. We know that angle B is congruent to angle D, right? Therefore, the two angles are congruent. Therefore, I can just plug in my expressions for those two angles. So my first expression is 6y plus 5. The other expression is 8y minus 17. I can set those equal to each other. We can solve. Boop. We get y equals 11. Plug it back in. Calculate the angle. We get 71 degrees. Okay, see if you can do these two. Go ahead and pause here. Pause. They're fishes. And hopefully you got these answers. Remember, the diagonals bisect each other. So that means that the two segments that make up a single diagonal are equal. Okay, and then 9.2 is the same thing but the opposite, right? So it's basically the converse of the properties. So instead of saying, oh, hey, we have a parallelogram, these are the properties, usually we'll get a shape, and we'll say these are the properties of the shape. Is it a parallelogram? So to be a parallelogram, basically both pairs of opposite sides of a quadrilateral. These are a little bit harder because we can't note here, some of these are pretty specific. So here, both pairs, right? We need both pairs of opposite sides of a quadrilateral to be congruent. Then we can say it's a parallelogram. There's a few others here. For this one, all we need is one pair of opposite sides of a quadrilateral to be parallel and congruent. So for this one, we'll draw some figures with these ones. So for this one here, bear with me. Here's my quadrilateral. Boop, ba-doop, ba-doop, ba-doop. This one we need both pairs of opposite sides. So we need to say that this side is congruent to this side, and this side is congruent to this side. Then Boom, that's a parallelogram. Okay, this one here, same sort of deal. This one says, hey, if one pair of opposite sides are parallel, so that one is parallel to this one. Oh my gosh, I used congruent marks. No, that's fine. Okay, yeah, that's fine. Okay, so they're parallel and they're congruent. Boop, boop, boop. Then it's parallelogram. I thought maybe I missed one. Also, obviously, is that the same ones before? Both pairs of opposite sides of quadrilateral are congruent. Well, one of these should say both sides are parallel, right? So this one is parallel to this one, and this is basically our initial definition of a parallelogram, right? If both pairs of opposite sides are parallel, then it's also a parallelogram. And then finally, sorry, one of these should say parallel. Write down parallel. The very last one, if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. Again, we have our boop, 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 nicest one yet. If the diagonals, should have done the diagonals a different color. That's a nice straight diagonal. If they bisect each other, so if this is true, looks like a flag, then the quadrilateral is parallelogram. Okay, so we can do some examples. But they're basically the same as before, where we just have to show that this figure is a parallelogram. So we have to show that these opposite sides are congruent. And we can do the or basically they're asking what value of x and y do we need to show that this is a parallelogram. So we set them as equal to each other and then calculate. Same one here. If this is a parallelogram, then the opposite angles are congruent. Therefore, 12w plus 8y is equal to 14w minus 1. Similarly, 9z plus 19y equals 11z minus 3. So we set these equal to each other. Solve, plug it back in. Oh, wait, what? Oh, no, these ones, they give us values. Yeah, so they give us values. We're just checking. Okay, so this one they put in 11. This one they put in 4.5. And we just plug it in. Is 118 equal to 118? Yes. Again, we plug in our values here. Is 62 equal to 62? Yes, so therefore is it a parallelogram? Yes, because both pairs of opposite angles are congruent. Sorry, I forgot they were doing that one a little bit different. So go ahead and pause here. Fishy theme. So for this one, we can say it's a parallelogram because a pair of opposite sides are, so for example this one, are both equal and congruent. This one here, we can say it is a parallelogram because the diagonals bisect each other, right? Because Jn is equal to NL and Mn is equal to Kn. Okay, that's all I got. Yeah, we'll do more stuff with this in a bit. Have a good one.